Welcome to Log Day. We are on section 5.4. We have a bunch of log properties today that we are going to do together. So first thing, we have this red box full of our log properties. By no means do you need to memorize these, but they're very, very helpful when simplifying. So I'm going to go through a couple of them just so that we understand where they come from. And since these are now our properties, we can use them at any point in our simplifying or our solving. Okay? So the first property is log base b of b equals 1. Also, log base b of 1 equals 0. Now let's make sure we understand where those come from. Remember, if we're in log form, the best thing to do is, most of the time, put it into exponential form. So if I rewrote this, it would be b to the first equals b. Well, we know that's true. That's what the first statement's saying. The next one's saying b to the 0 power equals 1. Well, we also know that's true because anything to the 0 power is 1. So you do not need to actually put it into exponential to show that it's true. You can just leave it just like this and say it equals 1 or it equals 0. Step 2 is saying log base b of p times q is equal to log base b of p plus log base b of q. Okay, so looking at these, it kind of reminds me of my exponent rules in a way, where if you are adding like bases, then you'll multiply your exponents. Same thing here. When you add like bases, you're going to multiply your arguments. Step 3 is if you're subtracting like logs, you're going to divide the arguments, just like exponent rules. Then you have number 4. Number 4 is really important. Notice it's saying log base b of p raised to the n is equivalent to n times log base b of p. The only thing that changes is the placement of that n. This is a very, very good fact to know because if the n is the exponent right here, you can then bring it down in front. Definitely when we're starting to solve, this is going to be crucial. Okay. Then you have number 5 and 6. Again, you could simplify it into exponential form like we did above. But these are known facts that we're going to use throughout this video. Let's jump into our first example here, example 1, using the facts that we have above. Notice we have like logs and they're being added. So you're going to take that like log, so log base 10, and then you're going to multiply your arguments. So you're going to get log base 10 of 100. We're then going to simplify this and bring it into exponential form. So it's going to be 10 raised to some argument is going to equal 100. We're going to get like bases. So that's going to be 10 squared. Like bases equal exponents. So we know x is going to equal 2. So you simplify your log, and then you can bring it into whatever form to find your answer. Let's look at example 2. We again have like logs, so we have log base 8. And now we're subtracting, so that means we're going to divide our arguments. So you get log base 8 of 8. This is interesting. If you look at fact number 1 right here, log base b of b, log base 8 of 8, I can just jump right here to say it's 1 and be done. based on the first property. If you wanted just to check to make sure, put it into exponential. X to 8 to the x power will equal 8. Well, notice that's to the first, so x equals 1. So if you want to even write this as equals x, that's perfect, or just 1, both are accepted. Next, we're going to use log properties to shorten expressions. Again, we're going to use those properties above. This time we have to express as a single logarithm with a coefficient of 1. Okay, first thing, we have 1/2 log base b of x. So I need to simplify that. The best way to simplify it is using the property above, property 4, is to move that 1/2 to be the exponent. It's going to be log base b of x raised to the 1/2 power. Can't really do much with this next term, so I'm going to go ahead and just rewrite it. And now we have the coefficient of 1, right? That's nice. I have like logs that are being subtracted. Since I have these like logs, I'm going to put that log here. I am subtracting, so that means I'm going to divide my arguments. And you are good just to leave your answer like that. You have simplified the log with a coefficient of 1. Example 4 is a little more complicated, but we can do it together. Look at that, the fact that they're all ln functions. That's awesome. So that means they all have the same base e. Let's get that coefficient of 1. So nothing actually will change in the first problem. But using step 4, this 2 in front can pop up to the top. So it's ln of 1 over x plus 3 squared. Same thing with that 4. It doesn't need to be there. It can pop up to the top and become the exponent. Notice I have a coefficient of 1. I have like bases. They're all ln of e. And they're being multiplied. Oh, sorry, they're being added. So you're going to take that like log, but you're now going to multiply all the arguments using our properties from above. You have the like logs being added, so you're going to multiply the argument. When I do so, I'm going to do some simplifying here. I'm going to FOIL factor this. Multiplying. I'm going to rewrite this just so that it's clearer to me. Stuff's going to cancel here. This will go away with one of those. So I'll be left with ln in the numerator, x minus 3 times x to the 4th all over x plus 3 on the bottom. You are more than welcome to leave your answer like that. If you want to just go a little bit further, you could write it as ln of x to the 5th by distribution, 3x to the 4th over x plus 3. And that is how you took all these logs and shortened it into one single logarithm. Well, if we can go that direction, how about we now expand? So here we're going to use log properties to expand this expression. We're going to write each of the following as sums, differences, and constant multiples of simpler logarithmic expressions. We want to express each answer in such a way that no logarithm of products, quotients, or powers appear. Okay, let's try this out. So part A, we have log base 10 of square root of 3x. That is very simple. That's kind of what we just got it to in the last part. We're now going to unravel it and make it more complicated. One thing that's good to do is always get that exponent. Instead of having the square root, you can write it as 1/2. Using property 4 from our red box, realize that 1/2 can now come in front. I have a base that has an argument with multiplication in it. So to undo that multiplication, if you have like bases, that meant that you just added those arguments. And now this is as simple as possible. I took away the multiplication because remember it wanted no products in there. I took away the powers because of that 1/2 I moved to the front. And this is as simple as it can get. Part B, you have log base 10. This one, oops, sorry. Does not look like a 10. You have log base 10 of cube root 2x over 3x squared plus 1. I'm going to ask you to pause the video, doing everything we did in part A, make this more complicated. Unravel it into a bunch of different log functions. Let's see how you did. Hopefully you got this answer. We did the same step as part A. You first take away that cube root, make it a third, bring that to the front using property 4. Then you need to break up all the multiplication and division. So I broke up the division with the subtraction sign of my like logs, and then I broke up my 2x as my argument with addition. If you got that wrong, please correct it. We're going to try part C now. So part C is ln in the numerator x squared square root of 2x minus 1 over denominator of 2x plus 1 raised to the 3/2. I'm going to have you pause one more time. Try to simplify this one into more individual log functions. Good luck. Let's see how you did. First thing you want to do is get rid of that square root and make it a power of 1/2. Then you just have ln in terms of two terms being multiplied and divided by the last. So you're going to break that up into addition between like ln's, and then you're going to subtract the ln that's being divided. Then the last final step is taking that exponent of 2 and bring it to the front, exponent of 1/2, bring it to the front, and exponent of 3/2, bring it to the front. Okay? If you want good practice, I would take this and now try to simplify it. Can you get the same answer as part C? So those last two parts, we made something more complicated, and then we made it simpler. So kind of they do the opposite of each other. Last part is practice, practice, practice with a partner. I'm going to start you off with a couple of them, and then I'm going to let you finish them off as a little partner challenge for extra credit. Notice we are given that log base b of 2 equals a. That's super important. We're also given log base b of 6 equals b. Super important, because all of our answers need to be in terms of a and b. So looking at the first one, you'll see that one's done for you as a solution. Log base b of 8. Well, you can rewrite log base b of 8 as log base b of 2 cubed. And the reason I'm doing that is because I'm trying to get this to look like up here, one of those. In this case, I get it to look like a. Using the properties that we talked about so far, you can bring the exponent down in front, and look at that. You have 3. A. So you're going to try B, C, and D using that idea that you want to get log base B of 2 or log base B of 6, because that would be A and B. I'm going to show you, though, part E. That one's a little tricky. So I'm going to go through part E with you, which is log base square root of B is 2. Again, my goal is to get either log base B of 2 or log base B of 6, so I can replace with A or B. Okay, first thing I'm going to do is I'm stuck in log. I don't know what to do. I'm heading to exponential. So it's going to be square root of B, my base, raised to an unknown exponent, is going to equal 2. I can rewrite this as B to the 1/2 times x equals 2, which is really B to the x over 2. I think that's easier to look at. Now I need to get this back into log, right? Because all my answers are in terms of log. Well, I can do that now. Now that I simplified the exponent, it might be easier. So getting it into log, it's going to now be log base B. The argument is 2, but this time it's going to equal x over 2. We're getting close. I see a log base B of 2. That's helpful. I'm just going to quickly simplify by multiplying both sides by 2. And I'm going to get 2 log base B of 2 equals x. This portion right here, if I look above, is the letter A. So I really get this to be 2a equals x. Or if you just want to simplify to 2a, I'm good with that. Again, your goal is to always have log base B of 2 or log base B of 6. I'm going to leave F as well for you to try that. My hint to you, use those properties. If you want some extra credit, get those done. We'll check them in class, and I'll see you soon.